Okay. So, properties of expectation, properties of expectation of one-dimensional random variable. Right. So here first I will explain the properties. Right. So if x is any random variable, either it may be discrete or it may be continuous, then the first property, expected value of k equal to k, where k is any constant, where k is any constant. Next, second, expected value of k into x. So that will be k into expected value of x, same where k is any constant. Next, third property, expected value of
The screen is not visible.
screen is not visible.
No, sir.
Now,
Sir. Yes, sir.
is it visible?
Sir. Yes, sir.
Now visible, na?
Yes.
Oh. So here the first property, that is expected value of k equal to k, where k is any constant. Then second property, expected value of kx, that is equal to k into expected value of x, where again k is any constant. Then third property, ax plus b, expected value of ax plus b is equal to a into expected value of x plus b, where a and b are constants, where a and b are constants, right? So now we are going to prove these three properties with respect to continuous case as well as discrete case, right? So now first we go for discrete case proofs, right? So proof for discrete case, right? So here let x will be x be a discrete random variable, a discrete random variable with values x1, x2, x3, and so on up to xn with respect to probabilities with the respect to probabilities p1, p2, p3, and so on up to pn, right? So then now here we are going to prove the first one, right? So first one, what are they given? Expected value of k equal to k, where k is any constant, right? The meaning of that is nothing but, say for example, expected value of 2 equal to 2, expected value of 2025 equal to 2025, expected value of 1996 is equal to 1996, like that. So expected value of any constant is equal to some constant itself, right? So now how we are going to prove this? in generally expected value of k equal to k, where k is any constant, right? So now, what they given? Expected value of k, right? So what our definition says? What our definition says? Expected value of x equal to summation I running from 1 to n xi into pi, right? So this is what our definition. Now, according to that, summation I running from 1 to n, instead of here x we have, so that's why it is xi. So here what we have? K, right? So just we take k into pi. This is by definition itself, right? So now expected value of k equal to k is outside. Sorry, I will take k outside because it is independent of the variable. So it will be k into summation I running from 1 to n pi. So this will be expected value of k equal to k into 1, that is k. Then why it is summation I running from 1 to n pi equal to 1? Why means we know that sum of all probabilities is equal to 1, right? Sum of all the probabilities equal to 1. So that's why it is nothing but sum of all the probabilities. So k into 1, that is k. Clear? Very short. All proofs are very simple and very short. So I hope it's clear. Next, I will move to the second one, right? So second, expected value of k into x. Same, apply the definition. Summation I running from 1 to n. Instead of x, what we have? We have kx. So kx is a variable now into pi. Again by the definition itself. So expected value of kx equal to, we'll take k outside. So then what we have? Summation I running from 1 to n xi as it is and into pi as it is. So k into x, expected value of k into x equal to k into, this is nothing but our expected value of x, right? So this is our second proof. Now, third one, what we have third one? Expected value of ax plus b. Same, first apply the definition, that is summation I running from 1 to n. Instead of x, what we have here? Ax plus b. So ax, right? So we are taking ith variable I running from 1 to n. So it is I plus b, right? Into pi. Clear? Is it clear how we consider? By using basic definition. Now equal to summation I running from 1 to n. So apply pi inside. So that will be a into xi pi plus then summation I running from 1 to n b into pi. So here out a is a constant. We'll take outside the summation sign. So a into summation I running from 1 to n xi pi plus b is again, it is a constant, I mean real constant. So we'll take outside the summation sign. So summation I running from 1 to n pi, right? So which is equal to a, this is nothing but definition of expected value of x, plus b, this is nothing but into 1. So hence expected value of ax plus b is equal to a into expected value of x plus b, right? So this is what the third proof. And we proved with respect to discrete variable, right? So when you consider general examples, sorry, not general, particular examples. See, first one, expected value of 2025 is equal to 2025. Second, expected value of kx. Say, for example, expected value of 2025 into x is nothing but which is always equal to 2025 into expected value of x. That is k into expected value of x. Third case, what do we have format? Expected value of ax plus b. So expected value of 2025x plus 2026. So this is equal to what? A into expected value of x plus b. This is nothing but 2025 expected value of x plus 2026. Right. So like this, we have the these what we call the properties of expectations. Right. So among these three properties, if you have any doubt, you can ask. You can unmute yourself and you can ask. If it is clear, I will go to the same proofs with respect to continuous case.
Okay, sir.
Okay. So now we'll move to the proofs of the same properties with respect to that continuous case, right? Continuous case, right? So now let x be continuous a random variable having f of x as its probability density function, probability density function. Then first one, what do we have first one? Expected value of k, the answer should be k, right? So for continuous case, what is our expectation formula? Expected value of x equal to integration minus infinity to infinity x into f of x dx. Why we are multiplying x means we want expected value of x. So whichever term is here inside the bracket, we are writing that same term here, then distribution function or probability density function of that x, right? So now, so here what we have instead of k, what we have here? Sorry, instead of x, what we have k. So integration minus infinity to infinity k f of x dx by our basic definition. So k is a real number. I will take outside the integration k equal to, sorry, k into integration minus infinity to infinity. What we have here? Only f of x dx, right? This is equal to k into 1 again, right? Because we know that properties of PDF, I mean properties of density function, the second property, the first property will be f of x should be greater than or equal to 0 for all x belongs to the closed interval a comma b. Second property, integration minus infinity to infinity f of x dx should be 1. This is second property, right? So here k into 1, this is equal to k. Clear? So I hope it's clear. Now, second, expected value of kx equal to same integration minus infinity to infinity k into x f of x dx, right? Sir told that whatever here we have and we are taking, and don't take f of kx, right? So just we are multiplying only probability of probability density function of x, not kx here, right? So here k is outside, minus infinity to infinity x into f of x dx we have. So this is nothing but k into, the meaning of this one is nothing but by our definition, this is expected value of x. So second proof is also proved. Expected value of kx is equal to k into expected value of x. The first proof will be expected value of k is equal to k. Clear? Now, next, third one, expected value of ax plus b. Expected value of ax plus b is equal to, same apply the formula, integration minus infinity to infinity ax plus b f of x dx. So this is nothing but integration minus infinity to infinity. I will multiply this f of x inside. So I will break the bond, that is a into x into f of x dx plus integration minus infinity to infinity b into f of x dx. So expected value of ax plus b is equal to, a is a real constant. I will take it outside the integration sign, a into integration minus infinity to infinity x f of x dx, x f of x dx, plus b is a real constant. I will take outside the integration sign, so b into minus infinity to infinity f of x dx, right? So expected value of ax plus b is equal to a into, this is nothing but expectation value of x plus b into, this is nothing but again the second property of the PDF is equal to 1. So hence we proved that a into expected value of x plus b, right? So any doubt in this proof?
No, sir.
Okay, now we'll solve numerical example depending upon these proof, right? So whatever we discussed, properties of not exponential, properties of expected values of some different criteria. Now we will solve numerical example on whatever we discussed up to here. Example. Given the following, given the following probability distribution, given the following probability distribution, they given distribution here x and p of x. So -2, -1, 0, 1 and 2. So here it is 0.15, 0.30, it's 0, 0.30 again, it's 0.25, right? Then their question is find, first one, expected value of x, second one, expected value of 2x plus 3, third one, expected value of 4x minus 5, fourth one, expected value of 2025x, and the last one, expected value of x square, right? Expected value of x square. So now how to find out for this means, already we know that expectation of x formula, right? So what we know? We know that expectation of x formula. What is that formula? We know that expected value of x equal to, which formula should I use? Anyone, you can tell. Either shall I use expectation I running from 1 to n xi pi, or integration minus infinity to infinity x f of x dx? Which formula should I use here? I'm audible or not?
Yes, again answer.
Which one? Integration? No. Why we go for integration here? Just to observe x. X means what? Continuous random variable or it is discrete random variable? Just check here. X equal to
Discrete, sir.
discrete. Discrete means what is the formula? Summation I running from here minus 2. No. Here minus 2 na first. Minus 2, minus 1, 0, 1, 2. So I running from minus 2 to 2 xi p of xi. Clear? Is it clear or not?
Yes, sir.
Usually we have the formula for discrete case. This is the formula for discrete case, right? And here x values are given. Discrete case only. So now expected value of x equal to. I think today only you solved the practical. Solved or not? So first x value is minus 2. Minus 2 into 0.15 plus minus 1 into 0.30 plus 0 into 0 plus 1 into 0.30 plus 2 into 0.25. So expected value of x equal to, right? So minus 2 into 0.15, that is around minus 0.3 minus, this is also 0.3 plus 0 next plus this is 0.3 plus it is 0.5, right? So here what will get the answer? This minus 3, this plus 3 get cancelled. 0.5 minus 0.3, the answer will be 0.2. So here what we got? Expected value of x equal to 0.2. Clear? Clear or not?
Yes, sir. Yes, sir.
Okay. So now how to solve the next one? Second one, what are they given? Expected value of 2x plus 3. How to solve? Can anybody try in rough page and can you solve or just you give the answer? What our property says? Expected value of ax plus b is equal to a into expected value of x plus b. This is our property, right? So here instead of a what we have 2, instead of b what we have 3. So this is equal to 2 into expected value of x plus 3. Instead of b what we have 3, right? By our previous knowledge we know that expected value is 0.2. So this will be 2 into 0.2 plus 3. This is nothing but 2 into 0.2. Now that is 0.4 plus 3. The answer will be 3.4. 3.4. Those who are trying, I think you got the same answer.
Yes, sir.
Okay. Next, third one. This is the third one question. Expected value of 4x minus 5. Expected value of 4x minus 5. How to solve? Same here, instead of plus b, here we have minus b. That's it, right? So here, as a corollary, you can just to remember, ax minus b is nothing but a into expected value of x minus b, right? So instead of a, what we have 4 into expected value of x minus 5. So 4 into expected value of x is 0.2 minus 5. So 4 into 0.2, that is 0.8 minus 5. 0.8 minus 5, your answer will be minus 4.2. Clear?
Yes, sir.
Okay.
Sir.
So now we'll go for the fourth one. That is expected value of 2025 into x. What is the answer? Fourth one.
2025.2.
0. No, I think it's what is the answer? Final answer 2025 into 0.2, 1200 and 1 to 1.2.5. So here expected value of kx, k is 2025 here, so it is k into expected value of x, that is 2025 into expected value of x, right? So 2025 into 0.2. What is the answer? We'll check.
405, sir.
405. 2025 into 0.2. That is exactly 405. Clear? I hope all four are very simple and we can get easily. The fifth one. What is the fifth one? That is expected value of x square. Fifth one is expected value of x square. How to find out expected value of x square? What our formula says? Expected value of x equal to summation I running from 1 to n, whatever we have here, that term in the form of I, then pi. So here what we have? Summation as it is. Instead of x, what we have? X square I pi. Right? In generally, suppose I want expected value of x cube. So summation expected I running from 1 to n xi cube pi. Suppose in generally, suppose I want x power n summation I running from 1 to n xi power n pi. Clear? So about this, we'll discuss in tomorrow's class why, how it is like this and all. Right? That is nothing but there we have one of the concept, that is expectation values of some functions, say g of x or f of x, like that. So now expected value of x square. What is the meaning of this? X summation x square into that p of I means the first term xi is minus 2, its square, right, into its probability, that is 0.15 into its probability, plus like this, its square, then multiply by its probability. Clear? So now next one, that is minus 1 is there. So minus 1 square and its probability will be 0.30 plus 0 square into 0 plus 1 square into 0.30 plus 2 square into 0.25. So expected value of x square equal to minus 2 into minus 2, it is whole square, minus 2 into minus 2, that is 4 into 0.15 plus 1 into 0.30 plus 0 into 0, that will be 0 again, plus 1 into 0.30 plus 2 square will be 4. 4 into 4 into what we have? That 0.25. Right? So now expected value of x square equal to, that is 4 into 0.15, around 0.6 plus 0.30 plus 0 plus again 0.30 plus 1, which is equal to 1 plus 0.3 plus 0.3, that is 1.6, 1.6 plus 0.6, that is 2.2, right? So expected, this is nothing but expected value of x square, right? So expected value of x square equal to 2.2. Clear? I hope you clear with all the examples.
Yes, sir.
Okay. So now, as a practice, we'll solve the same, same questions for the some one function, some for the PDF. If x has following PDF, if x has following PDF, that is f of x equal to 4x cube, 0 less than x less than 1, then find first one, expected value of x. Second, the same questions will take. What your second question? Expected value of 2x plus 3. Expected value of 2x plus 3. Third one, expected value of 4x minus 5. Fourth one, expected value of 2025 into x. Fifth one, expected value of x square, right? So already we know the concept expectation, how to get the expectation for continuous case, right? First one, expected value of x equal to what? Minus infinity to infinity x into f of x dx, right? So minus infinity is nothing but lower limit here, 0 to 1, x into 4x cube dx. So I will take 4 outside, integration 0 to 1, x, here x power 1, here x power 3, that is bases are same, power must be added, that is x power 4 dx. So this is nothing but 4 x power 5 divided by 5, 0 to 1. So this is nothing but 4 by 5 for expected value of x. Next, second one, same expected value of 2x plus 3. This is nothing but 2 into expected value of x plus 3. So 2 into expected value of x is 4 by 5 plus 3. This is nothing but 8 by 5 plus 3. We can easily solve. That is 8 plus 15 by 5. Right? So here
23 by 5.
expected value of 2x plus 3 equal to 23 by 5. Next, third one. Expected value of 4x minus 5 can be split into 4 into expected value of x minus 5. So 4 into 4 by 5 minus 5. This is equal to 16 by 5 minus 5. So 16 minus 15 by 5. The answer is 1 by 5. Clear?
So how it is 15 by 5? It's 25.
Sorry. It's, oh, yeah. Wait, Okay. 0.525, sorry. 25 by 5. Alright. So it is nothing but minus 9 by 5. Clear?
Yes, sir.
Okay. So now fourth one. That is expected value of 2025 into x. This is equal to 2025 into expected value of x. This is equal to 2025 into 4 by 5. So 5 on the. So 505 into 4. That is nothing but 1620. Yes or no?
Yes, sir. Yes, sir.
Now we'll go for fifth one, that is expected value of x square, right? So here expected value of x square for continuous case, integration minus infinity to infinity x f of x dx, x square into f of x dx. Suppose I want x cube minus infinity to infinity x cube f of x dx. Suppose I want f of x power n minus infinity to infinity x power n f of x dx, right? Like this. So here x square is there. So integration minus infinity to infinity x square f of x dx. So this is nothing but minus infinity to infinity x square 4x cube dx. But here our limits are 0 to 1. So here our limits are 0 to 1. Right? So now, which is equal to, this 4 is a real constant. I will take outside the integration sign. So 4 into 0 to 1 x square into x cube into dx. So 4 into 0 to 1 x power 5 dx. So 4 into x power 6 divided by 6, 0 to 1. So this is equal to 2 by 3. There are 2 by 3. 2 by 3 x power 6, 0 to 1. So it is 2 by 3. 1 power 6 minus 0 power 6. So this is nothing but 2 by 3 into 1. So that will be 2 by 3. Clear?
Yes, sir.
Okay. So now why we discussed finding of expected value of x square, right? So this expected value of x square means in our next class we are going to discuss, here also we discussed the finding the expected value of x square, right? Why means in our next class we are going to discuss about variance concept, right? So I told you expected value of x is nothing but equivalent to mean, or which is equivalent to average, right? So when we found the average, now we are going to find out the variance in the next class. So in terms of expectation, the variance is given by expected value of x square minus expected value of x whole square, right? So already we know that how to find out expected value of x only. right? So here, so as a practice, just I took how to find out expected value of x square also, right? So in next class, we are going to discuss about expected value of a certain function. Say for example, how to find out expected value of suppose instead of x square, suppose we have log x. How to find out expected value of e power x. How to find out, right? So next class we are going to find out expected value of certain functions, right? Log x is a function here, then e power x is one of the function. Like that, we are going to first I will give some introduction, the expected value of certain function. Then if possible, we will solve some examples. Then we'll go for the variance concept. Clear?
Yes, sir.
Okay. If you have any doubt in today's class, you can ask. So I hope in practical session, madam, tomorrow, sorry, not tomorrow, today morning, madam solved the continuous case and discrete case of finding expected values.
Yes, sir.
Okay. What about the regarding variance? Did she solve variance problems regarding variance problems? Okay.
Yes, sir.
Okay. So in detail, we are going to discuss about variances in tomorrow's class.
Sir,
Clear?
we have one doubt in practical. Ma'am have given one homework, but we are unable to solve. Can you solve that for us?
Okay. Just to tell me the question.
Okay, sir. Sir, can I show it?
But you need to present your screen. If possible, just to take a picture of that and send to my WhatsApp number.
Okay, sir.
In mathematical expectation, she given this problem.
No, sir.
Huh? F of x she given, right? This is only na.
Of x is equals to e to the power minus x, where x is greater than equal to 0. Where p of x is greater than 0 divided by x greater than.
Then you are going to find out expected value of, sorry, not expected, probability, right? You are going to find out this value, right? Yes or no?
Yes, sir.
Okay. So this is from what we call that? Bivariate distribution, right? This is from bivariate random variable. Actually, I thought to start the today's bivariate random variable, but unfortunately, due to meeting, I didn't conduct the class, right? So here I will give the hint. Then whenever I have tomorrow immediately I'm going to start. When I think tomorrow we have 12 to 1 class, right? So there we are discussing the bivariate concept, that is from unit number 2, but I will give the hint here, right? Is it divided by or conditional like this? Probability x greater than 2, given probability x greater than 1, or it is divided by? Tell me first.
So we don't know. Ma'am, today we told, ma'am told I will check and tell you tomorrow.
Okay. I will tell you, I will discuss the both the case. If it is divided by, how to solve. If it is given, means conditional probability, I will tell you, right? Okay. So here, what they given? They given distribution function. Capital F of X means distribution function, right? So to find out probability, I require, what is the meaning of how to find out probability X greater than 2? How to find out? Integration minus infinity, sorry, not minus infinity. Greater than 2, na? Probability greater than 2 up to upper limit, we don't know. Upper limit, we don't know means here, what is the upper limit of this range? X is greater than 0. We don't know exactly. So it is infinity. F of X dx. In this way, we need to solve. But what about F of X? Small f of X is not given. They given capital F of X, right? So what I told you, the relation f of X is equal to integration minus infinity to x f of X dx. And once I think yesterday only I told in the class, if I know capital F of X, how to find out small f of f of X? That is nothing but differentiation. If I know small f of X, take the integration, it will give capital F of X, right? Suppose I need small f of X with the capital F of X, just to take differentiation of capital F of X with respect to dx. So small f of X equal to differentiation of this e power X. What is the differentiation of e power X? E power minus X, sorry. Power X. Huh? Same? Same or like this? Which one is right? Second one. Second one means this one only, na? Yes, sir. Yes. Okay. So here, probability X greater than 2, sorry, 2 to infinity, right? E power minus into e power minus X dx, right? So now minus is outside the integration sign, 2 to infinity. Sorry, e power minus X dx. What is the integration of e power minus X? Minus integration of e power minus X is nothing but itself e power minus X divided by coefficient of this X. Coefficient of this X is -1, right? So minus e power minus X divided by -1. So this minus get cancelled. So 2 to infinity as it is. So probability greater than 2 is equal to e power minus X itself 2 to infinity. When we insert infinity here, first upper limit, e power minus infinity minus lower limit e power minus 2. We know that e power infinity, e power minus infinity will be 0, right? So it is 0 minus e power minus 2, right? Clear? Clear or not? This is nothing but minus e power minus 2. This is what probability X greater than 2. Similarly, find out X greater than 1. X greater than 1 means what? Probability X greater than 1 means what? Integration 1 to infinity minus e power minus X dx. Okay. You will get same as it is. The final answer will be like this. Minus e power minus 1, right? So suppose it is divided, right? Probability X greater than 2 divided by probability X greater than 1 means here minus e power minus 2 we have, here minus get cancelled. E power minus 2 divided by e power minus 1 will be your answer, right? Or you can take further, you can solve e power minus 2 into e power minus 1, it will be 1. So e power minus 2 plus 1, this is nothing but e power minus 1, right? E power minus 1 is nothing but 1 by e. Clear? 1 by e is nothing but what? 1 by 2.7 answer. Meaning of 1 by e is. Clear or not?
Yes, sir.
Okay. The second case, suppose it is given. Given means conditional. probability x greater than 2 given probability x greater than 1, right? So here what they given range of the x? X is greater than or equal to 0 means what? 0 to infinity taken. This is our range, right? Somewhere in our real line, we have 1 and somewhere we have 2, right? Now 3, 4 and so on up to infinity. What they given? The meaning of this one is nothing but what is our conditional probability concept? Conditional probability concept. Probability of A given B is equal to probability of A intersection B divided by probability of B. Here also probability of instead of A what we have? X greater than 2 intersection X greater than 1 divided by probability X greater than 1. What is the meaning of greater than 2 intersection greater than 1? Means it should be greater than 2 as well as intersection is there means common terms means it is greater than 1. It means that it is probability greater than 1 divided by probability greater than 1 already get cancelled. The answer will be 1. Without solving we can solve by this our basic preliminary knowledges. Clear or not? I hope from here to here you have doubt, right? Hello, am I audible?
Yes, sir.
Okay, so I think this kind of problems will be very rare. I think it's divided by whatever we solve na. This is the right question. Clear? So the answer will be 1 by E. Like this we can solve, right? So better. First I will stop the record.